All of you, welcome back. So we are starting new chapter. Aaron, good afternoon, good evening. Smridilaya, good evening. Adira, good evening. Vijusha, Adarsh, Aradi, Anigraha, Abhinav, all of you, good evening. What is our chapter name? System, particle and rotational motion. System, particle and rotational motion. Rigid body. First topic is rigid body. A rigid body has a definite shape. So what is the specialty of rigid body? Definite shape and also size. The distance between any two particles of the rigid body does not change even on the application of force. Even when we apply a force, the distance between particles of a rigid body will not change. See, I am applying a force on my forearm. So what happens? Distance between the particles of my forearm change. So is my forearm a rigid body? No. So what are the properties of rigid body? Definite size, definite shape. Distance between particles of a rigid body does not change even after application of a force. Even when we apply a force, distance between two particles of a rigid body does not change. Rigid body do have definite size and definite shape. Note down rigid body. മക്കളെ നോട്ട് ചെയ്യുക rigid body. Our topic is rigid body. Note down rigid body. Good evening. Abhishek, good evening. Sanusha, good evening. Varsha, Shivan, good evening. Please text noted once you are done. Noted rigid body. So what are the 3 points? Rigid body have definite size, definite shape. Distance between particles of a rigid body does not change even after the application of a force. Anju Arjun Krishnan V, AKV, Anton Kalashnikov, AK. Done? Good evening. Gauri Shivakumar, good evening. Pradeep Lakshman, good evening. Aaron, good evening. Noted. Aaron, noted. So, all of it done? What is the rigid body? Done? Is it done? Arju, good evening, good evening. Rigid body definition is done, right? All of you done? Yeah. Next point. Translatory motion. In a pure translatory motion, at an instant of time, all the particles of the body have same velocity. What is meant by translatory motion? If a body moves from A to B, suppose I am going from A to B. See, then my head is having same velocity, my hip is having same velocity, my arms are having the same velocity, my legs are having same velocity. Can we say my feet is moving at 30 km per hour, my head is at rest? No, you can't say. Can somebody say head is moving at 30 km per hour, but my legs are at rest? Can somebody say like that? If a body is in translatory motion, then all the particles of the body have same velocity. That is the concept. If a body is in translation, this figure doesn't belong here. This figure is not required here. In pure translation motion, at an instant of time, all the particles of the body have same velocity. Suppose I am going by car. Then suppose the speed of the car is 30 km per hour. So the person sitting inside the car is moving at 30 km per hour. The tires of the car is moving at 30 km per hour. The headlight of the car is also moving at 30 km per hour. All the particles of the body have same velocity in pure translatory motion. Aradi sir voice kelkunnilla. I think it might be your problem. What about others? In pure translatory motion, all the particles of the body have the same velocity. Yeah, Pradula, yeah, fine. Please note down translatory motion. That figure does not belong here. No need to draw the figure. We are discussing translatory motion. What is the specialty? All the particles of the body have the same velocity. Note here, no? Nikhil Rajan, good evening. Note here, translatory motion note here. Note. Next, translatory motion done. Next motion, rotationary motion. In the rotation of a rigid body about a fixed axis, every point of the body moves in circles. The circular path of the particle will be perpendicular to the axis of rotation. In rotation, the angular velocity omega, translatory motion, what was constant? Linear velocity was a constant, or simply velocity. In rotationary motion, what is constant? Angular velocity omega of all the particles of the body remains constant. Example, ceiling fan, potter's wheel, means Kushavan. Potter means what? This ഈ നമ്മൾ മണ്ണുകൊണ്ട് ഈ മറ്റേ വെസൽസ് ഒക്കെ ഉണ്ടാക്കില്ലേ, അതിന് കുശവന്റെ ആല എന്ന് പറയും. ഫോർ എക്സാമ്പിൾ, ഞാൻ ഈ റിങ് എടുത്തു. ഈ റിങ് എടുത്തിട്ട് ഞാൻ ഈ പാനലിട്ട് എന്നിട്ട് ഞാൻ അങ്ങനെ കറക്കാണ്. അപ്പൊ ഈ റിങ് കറങ്ങണത് പെർപെൻഡിക്കുലർ ആയിട്ടാണ് ആക്സിസ് ഓഫ് റൊട്ടേഷൻ. സോ ദാറ്റ് ഈസ് ദ റീസൺ വൈ ഇൻ ദ റൊട്ടേഷൻ ഓഫ് റിജിഡ് ബോഡി അബൌട്ട് എ ഫിക്സ്ഡ് ആക്സിസ്, every particles of the body moves in circles. Every particles of the body moves in circles. Circular path of the particle will be perpendicular to axis of rotation. See, this ring is in rotationary motion. The circular path or circular motion of this ring is perpendicular to what? Axis of rotation. Circular path and axis of rotation will be perpendicular to each other. And what is the specialty of circular or rotationary motion? All particles will have same angular velocity. Suppose I, along with my wife, my kids, went to giant wheel. Now what happens? In giant wheel, it is in rotationary motion. So what happens? Suppose I, along with my wife and 3 kids, on giant wheel. Giant wheel മലയാളത്തിൽ യന്ത്രൂഞ്ഞാൽ എന്ന് പറയും. ഇത് യന്ത്രൂഞ്ഞാൽ കറങ്ങുമ്പോൾ all particles of this giant wheel will have what? Same velocity. 30 radians per second, 30 radians per second. All cubicle. Cubicle means the box in which we sit. All will have what? Same velocity. Isn't it? അല്ലേ? നമ്മൾ ഈ ജയന്റ് വീലിൽ പോകുമ്പോൾ ജയന്റ് വീലിലെ ഓരോ ക്യൂബിക്കിലുള്ള ആൾക്കാരുടെയും വെലോസിറ്റി സെയിം അല്ലേ? വെലോസിറ്റിക്ക് മാറ്റം വരുമോ? All will have same angular velocity omega. Here, what is angular velocity? 30 radians per second. Remember, unit of angular velocity is what? Omega. See, this is axis of rotation. See, different circular motion or rotationary motion. Remember, this axis is perpendicular to what? Perpendicular to what? Plane of the circular motion. Any doubt? Nandana, good evening. Doubt na? ഡൗട്ട് ഉണ്ടോ? നോട്ട് ചെയ്യോ? ആർക്കെങ്കിലും ഡൗട്ട് ഉണ്ടോ? Angular velocity is same. Circular path will be what? Perpendicular to axis of rotation. Those are the 2 points which are needed. Note ചെയ്തില്ലേ? All of you done? Then it's a precision. Precision. What is meant by precision? That you have seen spinning of top. മലയാളത്തിൽ പമ്പരം കുത്തുക എന്ന് പറയും. അതേപോലെ നമ്മുടെ പെഡസ്ട്രിയൽ ഫാൻ കറങ്ങുമ്പോൾ when pedestrian fan rotates, the axis of the fan also rotates. Such motions are called what? Such motion is called what? Precision. In this type of motion, the axis of rotation also moves. Example, spinning of a top, an oscillatory table fan or a pedestrian fan. Pedestrian fan means what? The leaf of the fan rotates and also axis of the fan also rotates. So it is called what? Precision. What is its specialty? Axis also rotates. Note ചെയ്യടാ. Position done. Axis of rotation also moves. Next, rolling motion. So this was the first figure. Rolling motion is a combination of translatory motion and also rotationary motion. See, suppose there is a coin. When the coin rolls, what happens? There will be both the translatory motion and rotationary motion. Why so? Because when coin moves from one point to another, there will be what? Translatory motion. But when coin rolls, it also having a motion or rotationary motion along its axis. So rolling motion is a combination of both the translatory and rotationary motion. Rolling motion is a combination of translational motion and rotational motion. Rolling motion is a combination of translational motion and rotational motion. Note down rolling motion. See, for entrance students, I am telling you a small point. During rolling motion, the part of the body which comes in contact with the ground will have minimum velocity. At this point, velocity minimum. And the topmost point will have what? Maximum velocity. This point, maximum velocity. That for entrance, just a point to note down. During rolling motion, the bottommost body particle will have minimum velocity. Topmost particle will have maximum velocity. Note it down. Note it down. Note ചെയ്തില്ലേ? Next, center of mass. It is the point at which the entire mass of the body can be assumed to be concentrated. What is center of mass? It is the point at which entire mass of the body can be assumed to be concentrated. അതായത് ഒരു ബോഡിയുടെ ഫുൾ മാസ് കോൺസെൻട്രേറ്റ് ചെയ്തിരിക്കുന്നു എന്ന് നമ്മൾ അസ്യൂം ചെയ്യുന്ന പോയിന്റ് ഈസ് കോൾഡ് സെന്റർ ഓഫ് മാസ്. സപ്പോസ് ഐ വാണ്ട് ടു ബാലൻസ് ദിസ് പെൻ, ഐ ഷുഡ് apply a force in the opposite direction of center of mass. See, I want to balance this pen. See, I am applying center of mass at this point. So when center of gravity or center of weight also act vertically downward. So I am applying a force in the opposite direction of center of gravity. That is the reason why this pen gets balanced on my hand. I hope it is clear. മനസ്സിലായോ? Center of gravity is vertically downward and I am applying equal and opposite force. So that is the reason why I am able to balance this pen. What is center of mass? The point at which whole mass of the body assumed to be concentrated is called center of mass. I can also write center of gravity. Center of gravity. The point at which whole weight of the body can be assumed to be concentrated. Whole weight of the body can be assumed to be concentrated. Can be assumed to be concentrated. The point at which whole weight of the body can be assumed to be concentrated is called the center of gravity. In places near Earth's surface, center of gravity and center of mass both will be at the same point. Both will be at the same point for places near Earth's surface. But for a large height above the Earth's surface, center of gravity might be below center of mass. Center of massനേക്കാൾ കുറച്ച് താഴെയായിരിക്കും center of gravity എവിടെ for height above the earth surface. എർത്തിന്റെ സർഫസിലുള്ള മുകളിലേക്കുള്ള ഹൈറ്റ് വെച്ച് നോക്കുമ്പോൾ സെന്റർ ഓഫ് ഗ്രാവിറ്റി കുറച്ച് താഴെയായിരിക്കും ആരേക്കാൾ സെന്റർ ഓഫ് മാസിനേക്കാൾ. പക്ഷെ എർത്തിന്റെ സർഫസിനോട് ചേർന്നുള്ള സ്ഥലങ്ങളിലൊക്കെ എന്താ സെന്റർ ഓഫ് മാസും സെന്റർ ഓഫ് ഗ്രാവിറ്റി ബോത്തും സെയിം പോയിന്റിലായിരിക്കും. ഞാനിവിടെ ബാലൻസ് ചെയ്യില്ല ഈ പെന്നിനെ. ഇപ്പൊ ഐ എം സ്റ്റാൻഡിങ് നിയർ ടു എർത്ത് സർഫസ്, സോ ബോത്ത് സെന്റർ ഓഫ് മാസ് ആൻഡ് സെന്റർ ഓഫ് ഗ്രാവിറ്റി വിൽ ബി അറ്റ് ദ സെയിം പോയിന്റ്. ബട്ട് ഇഫ് യു ഗോ ടു എ ലാർജ് ഹൈറ്റ്, സെന്റർ ഓഫ് ഗ്രാവിറ്റി വിൽ ബി സം വാട്ട് ലെസർ ദാൻ സെന്റർ ഓഫ് മാസ്. അതിന് കാരണം the reason you will study in the next chapter, because as you move above the earth surface, gravity decreases. That you will study in the gravitation chapter. നോട്ട് ചെയ്യാടാ. നോട്ട് ചെയ്തോ? Center of mass, center of gravity. Next, center of mass in one dimension. Or next topic, center of mass in one dimension. See, I will draw it separately. X, Y, along x-axis at a distance x1 there is a mass m1. At a distance x2 there is a mass m2. What will be the center of mass of this system? So I am writing x suffix m, which means what? X coordinate of center of mass. Since it is in one dimension, there will be only x coordinate. How to find out that? M1 x1 plus m2 x2 divided by m1 plus m2. This is the equation for center of mass in one dimension. It is in x direction. Suppose these two are in y direction only, then it will be what? M1 y1 plus m2 y2 divided by m1 plus m2. Remember, both the x direction and y direction will not be happening at the same time, because we are discussing about center of mass in one dimension. So either masses will be along x direction or along y direction, but not both in x and y. So this, now if m1 is equal to m2 is equal to m, then center of mass of the x coordinate will be what? Mx1 plus mx2 divided by m plus m. So center of mass is equal to what? If you take m common, m into x1 plus x2 divided by 2m. So what happens? M gone. So center of mass is equal to what? X1 plus x2 by 2, if both are having equal masses. What is the equation? X1 plus x2 by 2. Any doubt? What is the heading? Center of mass in one dimension. Center of mass in one dimension. Please note it down. Center of mass in one dimension. Note it down. നോട്ട് ചെയ്താ? മക്കളെ മനസ്സിലാവണില്ലേ? സെന്റർ ഓഫ് മാസ് ഇൻ വൺ ഡയമെൻഷൻ ആണ് നമ്മൾ മനസ്സിലാക്കി. What about others? Done. Is it clear? Yeah. Then next, yeah, okay. Next, center of mass in one dimension itself for a system of n particles, center of mass will be what? X of Cm is equal to m1 x1 plus m2 x2 plus etc. plus mn xn whole by m1 plus m2 plus etc. plus mn. That can be written as center of mass is equal to sigma over I equal to 1 to n mi xi divided by sigma over I equal to 1 to n mi. Sigma over I equal to 1 to n mi xi divided by sigma over I equal to 1 to n mi. What is this mi xi? Initially I value will be 1, so m1 x1 plus sigma means summation. When I value becomes 2 plus m2 x2, it goes on like that. Now what is sigma over I equal to 1 to n mi is equal to what? Capital letter M. If you add the masses of each component, what you will get? Total mass. So you can write another equation for center of mass. Sigma over I equal to 1 to n mi xi divided by total mass capital letter M. Sigma over I equal to sigma over I equal to 1 to n mi is equal to what? m1 plus m2 plus etc. mn, which is what? Sigma, which is what? Total mass capital letter M. So what is portion of center of mass? So this is the equation for position of center of mass if there are n particles. Any doubt? Any doubt? Note ചെയ്യാട്ടോ, note ചെയ്യാം. അതിൽ ക്യാപിറ്റൽ ലെറ്റർ എം എഴുതാൻ കാരണം ടോട്ടൽ നമ്പർ ഓഫ് പാർട്ടിക്കിൾസിന്റെ മാസ് എന്ന് പറഞ്ഞാൽ എന്താ? അത് ടോട്ടൽ മാസ് ഓഫ് ദ ബോഡിയാണ്. പിന്നെ m1 m2 എഴുതണ്ട, ഒരു സിംഗിൾ ക്യാപിറ്റൽ ലെറ്റർ എം എഴുതിയാൽ മതി. ഡൗട്ട് ഉണ്ടോ? നോട്ട് ചെയ്യണ്ട. നോട്ട് ചെയ്ത് കഴിഞ്ഞാ? Next, two dimension. That you can easily understand, no problem. It's very easy to understand. Two dimension. What happens in two dimension? Consider three particles lying in a plane having coordinates x1, y1, x2, y2, x3, y3. So three particles having the coordinates, I can x, y. So three particles are there. First particle is having mass m1 and its coordinate is what? x1, y1. Let the second mass particle be m2 having the coordinate x2, y2. Let the third particle be this having the mass m3 having coordinates x3, y3. So what will be the x coordinate of x component of center of mass? m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. Y coordinate will be what? m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus m3. If both, not both, if all the three particles have the same mass, m1 equal to m2 equal to m3 is equal to m. So that what is answer? x1 plus x2 plus x3 by 3. What will be the y coordinate? y1 plus y2 plus y3 by 3. Now remember, if these three equal masses are at the three corners of an equilateral triangle, then what will be the position of center of mass? It will collide with the or coincide with the centroid of the triangle. It will coincide with the centroid of the triangle. Okay, it will coincide with this will be the position of the center of mass if three equal mass particles are at the three corners of an equilateral triangle. Then it will coincide with what? Centroid of the triangle. Any doubt? മക്കളെ മനസ്സിലായോ? Sorry. നോട്ട് ചെയ്തോ? Three masses at the three corners of the triangle, then it will coincide with what? Centroid of the triangle. So next, in 3 dimension, it is similar to that only. Similar to that only. What is that? Here I am making a small correction. Sigma over I equal to 1 to n mi xi. Here also I equal to 1 to n mi yi. I equal to 1 to n mi zi. Denominator it should be sigma or I equal to 1 to n mi. But that means what? M1 plus. Actually, denominator should be sigma over I equal to 1 to n mi. That is equal to m1 plus m2 plus m3 plus etc. plus mn, which is equal to what? Mass of the whole body, capital letter. This is the center of mass in 3 dimension. Please note it down. Please note it down. Center of mass in 3 dimension. Note it down. Center of mass in 3 dimension. Note it. Mass in 3 dimension. Noted, right? So center of mass in 3 dimension is also done. So next problem question. In the HCl molecule, the separation between nuclei of the two atoms is 1.27 angstrom. So whenever you get this kind of a question, separation is 1.27 angstrom. So better to place the first molecule at the origin. So I am placing H hydrogen at the origin. So what will be the coordinate? X equal to 0. And chlorine is at a distance. Separation is 1.27 angstrom. So what is the distance between hydrogen and chlorine? 1.27 angstrom. Calculate the approximate location of the center of mass. It is given chlorine atom is nearly 35.5 times as mass as hydrogen atom. So mass of hydrogen is what? Mass of hydrogen is equal to m. So mass of chlorine is what? 35.5 times m. So what will be the equation? We have to find out position of center of mass. What is the equation? Position of center of mass in x direction in one dimension. m1x1 plus m2x2 divided by m1 plus m2. Here instead of m1 we have mass of hydrogen m. Here we have mass of hydrogen m. Mass of chlorine is what? 35.5 m. The separation between them 1.27 angstrom. See, separation is given as 1.27 angstrom. So for convenience, I am placing hydrogen at the origin. So what will be the coordinate of hydrogen? X coordinate of hydrogen 0. So what will be the x coordinate of chlorine? 1.27 angstrom, because their separation is what? 1.27 angstrom. So m1 into, what is the position of hydrogen? m1 into 0 plus 35.5 m, mass of chlorine into 1.27 angstrom divided by m plus 35.5 m. What is m? What is hydrogen? Hydrogen mass m. Chlorine mass is what? 35.5 m. So I am taking m plus 35.5 m will be what? 36.5 m. That gets cancelled with the numerator m. So what I will get? 35.5 into 1.27 angstrom. So what is the answer? 1.23 angstrom. 1 angstrom is equal to how much meter? 10 raised to minus 10 meter. For those students who doesn't know this is called angstrom. 1 angstrom. 1 angstrom is equal to 10 raised to minus 10 meter. Doubt undo? Separate ചെയ്ത് കാണിക്കണോ? എങ്കിൽ പറഞ്ഞോ, separate ചെയ്ത് കാണിക്കാം. മനസ്സിലാവില്ലെങ്കിൽ സെപ്പറേറ്റ് ചെയ്ത് കാണിക്കാം. I can do it separately if you are not able to follow the problem. കേട്ടാ All of you done? Kanya. Next problem. Next problem example of motion of center of mass. Suppose a radioactive nuclei radium disintegrates into helium and radon. Rn stands for radon, Ra stands for radium. So even after disintegration, center of mass will continue the same position. Why? Center of mass will not change. Why? Because center of mass is like in the radioactive decay is due to internal forces. What is the reason behind radioactive decay? Internal forces. Internal forces cannot change center of mass. Consider the splitting of the heavy nucleus radium Ra into lighter ones helium and radon. The center of mass of the radium nuclei was initially at rest. After decay, the two nuclei helium and radon move in what? Opposite direction. Still, the center of mass will be at the same position, such that the center of mass is again at rest. Why it happens? Why even after radioactive disintegrations, position of center of mass is not going to change? Why it's so? The reason is that explanation. Radioactive decay is caused by what? Internal forces. Internal forces cannot change what? State of center of mass. Internal force എന്ത് ചേഞ്ച് ചെയ്യാൻ പറ്റില്ല? സെന്റർ ഓഫ് മാസ് ചേഞ്ച് ചെയ്യാൻ പറ്റില്ല. അതുകൊണ്ടാണ് അത് അങ്ങനെ നിൽക്കുന്നത്. Sir, please explain once more. ആദർശ് ഇവിടെ റേഡിയാക്റ്റീവ് ന്യൂക്ലിയർ ആയിട്ടുള്ള റേഡിയം ഉണ്ടായിരുന്നു. കുറച്ചു നേരം കഴിഞ്ഞപ്പോൾ ഈ റേഡിയം ഡിസിൻറ്റഗ്രേറ്റ് ചെയ്തു. ആരായിട്ട്? ഹീലിയം റാഡോൺ ആയിട്ട് ഡിസിൻറ്റഗ്രേറ്റ് ചെയ്തു. ഈ ഹീലിയം റാഡോൺ ഏത് ഡയറക്ഷനിലാണ് പോവുക? ഓപ്പോസിറ്റ് ഡയറക്ഷനാണ്. So when you calculate center of mass will be again at the same position. Center of mass does not change. Why? Because in radioactive nuclei disintegration, what is the reason behind radioactive disintegration? It is due to internal forces. Internal forces cannot change center of mass. I can give you another example. Suppose a bomb shell is moving in a projectile path. At a particular point, bomb shell explodes into two parts. They will move in opposite direction. So what happens to center of mass? Center of mass will continue the same position. Again, explosion is caused by what? Internal forces. Internal forces cannot change center of mass. Here the problem is that students will be thinking, sir, originally this much radium was there. Now a certain portion is going to this side, certain portion is going to this side. What is center of mass? It is the point at which whole mass can be assumed to be concentrated. That point will be exact in between these two opposite points. Now, it is not compulsory that center of mass should be within the body. For example, if you take this ring, I have one ring on my finger. What is the position of center of mass of this ring? It will be here. It is not within the body. It is outside the body. So when you expand the ring, again center of mass will be at the same position if there is equal expansion. Similarly, radium was here. Now it explodes to what? It disintegrates to what? Helium and radon. So this was original radium, radioactive after disintegration. This is the position of center of mass. The problem is that students will be expecting, sir, how can radium be at the same position? No, radium is not at the same position. Position of center of mass is at the same position. Radium have disintegrated into two different elements, helium and radon. But its center of mass will be at the same position. അതാണ് മനസ്സിലാക്കേണ്ട പോയിന്റ്. അല്ലാണ്ട് റേഡിയം അവിടെ തന്നെ ഉണ്ടെന്നല്ല അതിന്റെ അർത്ഥം. സെന്റർ ഓഫ് മാസിന്റെ പൊസിഷൻ മാറൂല. സെന്റർ ഓഫ് മാസിന്റെ പൊസിഷൻ മാറണമെങ്കിൽ എക്സ്റ്റേണൽ ഫോഴ്സ് കൊടുക്കണം. റേഡിയാറ്റീവ് ഡീകേ ആണെങ്കിലും എക്സ്പ്ലോഷൻ ഓഫ് എ ഷെൽ ആണെങ്കിലും ഇറ്റ് ഈസ് ഡ്യൂ ടു ഇന്റേണൽ ഫോഴ്സ്. ഇന്റേണൽ ഫോഴ്സ് കനോട്ട് ചേഞ്ച് സെന്റർ ഓഫ് മാസ്. ഇറ്റ് ഈസ് നോട്ട് കമ്പൽസറി ദാറ്റ് സെന്റർ ഓഫ് മാസ് ഷുഡ് ബി വിത്തിൻ എ ബോഡി. ഒരു ബോഡിയുടെ ഉള്ളിൽ തന്നെ ആവണ സെന്റർ ഓഫ് മാസ് ഇല്ല. ഫോർ എക്സാമ്പിൾ റിങ്ങിന്റെ കേസ്, റിങ്ങിന്റെ ബോഡിയിലല്ല സെന്റർ ഓഫ് മാസ് ഇരിക്കണേ. ഒരു ഐഡിയ കിട്ടിയെന്ന് ഞാൻ വിചാരിക്കുന്നു ആദർശ്. ഐ ഹോപ്പ് യു അണ്ടർസ്റ്റാൻഡ്. നോട്ട് ചെയ്തിട്ടല്ലേ? Done. So next, explosion of a shell. Consider a shell moving under the external force of gravity. The explosion is caused by what? Internal forces, which cannot change the center of path of the center of mass. See, the bomb shell is going in a parabolic path. At this moment, what happens? Explosion happens. Now, please understand that, okay, one part of the bomb shell moving will be gone to this side, other part in the opposite side. So what happens to center of mass? Center of mass will continue the same position. Path of center of mass. Path of center of mass will be same only, because bomb shell is what? Explosion of the bomb shell is what? Due to internal forces. Internal forces cannot change what? Center of mass. ഷെല്ലിന്റെ എക്സ്പ്ലോഷൻ എന്താ? ഇന്റേണൽ ഫോഴ്സാ. ഇന്റേണൽ ഫോഴ്സിനെ എന്ത് ചേഞ്ച് ചെയ്യാൻ പറ്റില്ല? സെന്റർ ഓഫ് മാസ് ചേഞ്ച് ചെയ്യാൻ പറ്റില്ല. ഡൗട്ട് ഉണ്ടോ? So the layer done. What about others? So even after the explosion, center of mass will be same. It doesn't vary. Earth of the center of mass will be same, intact, no change. Done. Next, direction of angular velocity that we already discussed. Angular velocity is denoted by omega. Omega is equal to rate of change of angular displacement. Now, what is alpha? Angular acceleration, that is d omega by dt. What is alpha? D by dt of, instead of omega, I can write d theta by dt. So, alpha is equal to what? D square theta by dt square. What is linear velocity? V, dx by dt. In translatory motion, we have velocity dx by dt. In rotational motion, in acceleration, we have dv by dt, which is what? Acceleration is d by dt of what? Dx by dt. So, acceleration is equal to what? D square x by dt square. D square x by dt square. Note it down. Vector form, what is the equation for? What is the relation between linear velocity and angular velocity? V vector equal to omega vector cross r vector. V vector is equal to omega vector cross r vector. Note here. What is alpha? Alpha is what? Angular acceleration. Angular acceleration. If a body, now it is direction of angular velocity is given by right hand rule. It means what? If a body is in rotating in this direction, then the thumb will show the direction of angular velocity. Here, thumb will show what? Direction of angular velocity. That we know because all the cross product direction is given by right hand thumb rule. Cross product, no, the direction will be given by what rule? Right hand thumb rule. Direction of angular velocity is done. Next, angular acceleration we have discussed. Unit of angular velocity unit is what? Angular velocity unit radians per second. Angular acceleration unit radians per second square. Radians per second square. Angular acceleration unit. Angular velocity unit radians per second. Angular acceleration unit radians per second square. That we have discussed the unit SI unit of angular acceleration radians per second square. Now torque. Torque is a force which produces turning effect. Torque produces what? Turning effect. Definition. Torque or moment of force. Torque, another name is what? Moment of force. One more name is there, rotational force. What is torque? Rotational force. About an axis of rotation is measured as the product of the magnitude of the force and the perpendicular distance between the line of action of the force and axial rotation. For example, that we know if there is a door connected to a wall by hinges, then if you want to move this door, you should have what? Torque. What is the definition of torque? Distance from the axial rotation into force. Torque tau vector equal to R vector cross F vector. Torque tau vector is equal to what? RF sin theta. If theta is equal to 90 degree, torque equal to RF. So what is the importance here? Here, by increasing distance from the axial rotation, you can reduce the force to get the same torque. For example, we need a torque of 10 Newton meter. So how to get 10 Newton meter? Put radius 10 meter into force 1 Newton. So you will get what? Torque. So if somebody tells you to fix the door handle, where you should fix? At the free edge. Why? Because this is the axial rotation. Because based on this axial rotation, the door rotates. If you fix the door handle here, the distance from the axial rotation increases. So with less force, you can turn the door. This we have discussed during cross product. So where you should fix the door handle? It should be kept at the free edge. What is the advantage of fixing door handle at the free edge? Distance from the axial rotation will be high. That means R will be high. So with less force, you can turn the door. Any doubt? ഇത് മുമ്പ് ഡിസ്കസ് ചെയ്തല്ല. ഡൗട്ട് ഇല്ലല്ലോ? ഡൗട്ട് ഉണ്ടോ? Done, right? So torque is also done. So let's continue. Torque equal to force into perpendicular distance that we have covered. Direction of torque is given by right hand rule. It is not new, because we know all the cross product direction is given by right hand rule. SI unit of torque is what? Distance into force. So meter Newton or Newton meter. Dimensional formula ml square t raised to minus 2. Torque has the same dimension of work energy. We know that in the first chapter. Torque, work, energy have the same dimensional formula. Torque equal to Rf sin theta. Theta 90 degree, torque equal to Rf. Torque in component form that we already know. I cap, J cap, K cap, X that we know. We know that, no, because we have seen in cross product. Now, door handles are fixed at the free edge. Why? What is the unit of torque? Newton meter. What is the dimensional formula? ml square t raised to minus 2, which is same as what? Work done and energy. Torque equal to force into perpendicular distance. By fixing door handles at the free edge, we increase the perpendicular distance to the point at which the force is applied. So for a given applied force, torque will be maximum. With the less force, in order to get less force at the maximum torque, we will be increasing the perpendicular distance. We will be always trying to increase the perpendicular distance. We will be always trying to increase the perpendicular distance. Noted, right? So next question. Angular momentum. Angular momentum is a very important one. Angular momentum. Angular momentum. Angular momentum of a rotating particle about an axis of rotation is the moment of linear momentum. L vector equal to R vector cross P vector, which also we have discussed before. L equal to RP sin theta, theta 90 degree. L equal to L equal to RP sin theta. What is L vector is equal to R vector cross P vector. Angular momentum. This is the relation between angular momentum and linear momentum. Momentum possessed by a body in rotational motion, angular momentum. Momentum possessed by a body in translatory motion or linear motion, linear momentum. What is the relation? L vector equal to R vector cross P vector. P vector equal to what? Mass into velocity. So L vector equal to R vector cross what? MV. So L equal to what? L equal to RP. Sorry. L equal to RP sin theta. What is momentum P? Mass into velocity. So L equal to what? MVR sin theta. Now if theta is equal to 90 degree, sin 90 is equal to what? So angular momentum L equal to what? MVR. What will be the unit? Unit of angular momentum will be what? Mass kilogram, velocity meter per second. Mass kilogram, velocity meter per second into distance radius meter. So what is the unit? Kilogram meter square per second. This is the unit of what? Angular momentum. Any doubt? It's the equation for angular momentum. L equal to mvr sin theta. SI unit is what? Kilogram meter square per second. Dimensional formula ml square t raised to -1. ഇവിടം വരെ നോട്ട് ചെയ്യുക കേട്ടോ. ഇത് എഴുതണ്ട, ഈ ബോക്സിലുള്ള എഴുതണ്ട, ഇവിടം വരെ നോട്ട് ചെയ്യുക. ആംഗുലർ മൊമെന്റം. The direction of angular momentum is perpendicular to r vector and p vector. It is also given by right hand rule, that we know, because example for cross product, all example for cross product direction given by right hand rule. L vector equal to r vector cross p vector, b vector equal to omega vector cross r vector, a vector equal to alpha vector cross r vector, tau vector is equal to what? R vector cross f vector. All of this direction given by which rule? Given by right hand rule. Right hand rule. All of this direction is given by right hand rule. Any doubt? Any doubt? മക്കളെ ഡൗട്ട് ഉണ്ടോ? ഇത് ഞാൻ ഇന്ന് എടുക്കണില്ല. റിലേഷൻ ബിറ്റ്വീൻ ടോർക്ക് ആൻഡ് ആംഗുലർ മൊമെന്റം നാളത്തെ ക്ലാസ്സിൽ എടുക്കണുള്ളൂ. ഇന്ന് എടുക്കണില്ല അത്. നോട്ട് ചെയ്താ? What is the unit of torque? Newton meter. What is the unit of angular momentum? Kilogram meter square per second. What is the dimensional formula for angular momentum? ml square t raised to -1. What is the dimensional formula for torque? ml square t raised to -2. Remember, torque, work done and energy have the same dimensional formula. Note the examples of cross product. All the cross product physical quantities direction is given by right hand rule. What are the examples? These are example for cross product. Example for dot product is what? Cross product. What are the example for dot product? Dot product examples are what? Dot product examples. First one, work done. Second one, work done is equal to what? F vector dot S vector. Power is equal to force vector dot velocity vector. And one more thing, magnetic flux is equal to B vector dot A vector, which you will study in second year. Another example for dot product is magnetic flux, which is B vector dot A vector, which is L equal to mvr. Not clear. L is angular momentum. See, what is momentum? Momentum is equal to momentum P equal to mass into velocity. Mass M into velocity V. That you can understand, because when you are hit by original cricket ball, it will be really paining for you. Why? Because it is having more mass, so more momentum than the plastic ball or tennis ball with which we play. So higher the velocity, higher the mass, greater will be the momentum. The same momentum, if a body, if a stone is attached to a string and you are rotating this stone in circular motion, then that stone is also having momentum. That momentum is called angular momentum, because it is in the momentum possessed by a body in rotational motion. When the stone, after the rotation, when the stone hits you, it will be really paining for you, because it is having angular momentum, which is L vector, which is R vector cross P vector. That is the relation between linear momentum, that is momentum in translatory motion, and momentum in rotationary motion. So what is the equation for momentum in rotational motion? MVR. Why? R vector cross P vector is RP sin theta. Is suppose theta equal to 90 degree, sin 91. Then R equal to what? Then R equal to what? R into P. That P is what? Mass into velocity. So angular momentum L equal to what? MVR. This is the angular momentum possessed by a body in rotationary motion. This is the linear momentum possessed by a body in translatory motion. What is the relation between them? L vector equal to R vector cross P vector. This body is clear alla? ഇപ്പോഴും മനസ്സിലായില്ല? L equal to R, MVR is equal to L equal to MVR equal to L equal to R vector cross P vector. MV R into, instead of P we are writing MV into sin theta. So L equal to MVR sin theta. Then I think in the next portion you have doubt. See, L equal to MVR. But in the second chapter we know V equal to R omega. So L equal to M into R omega into R. That means L is equal to what? MR square omega, which is another equation for angular momentum. Because we got L equal to MVR, but we know that in second motion in a plane, we know that relation between linear velocity and angular velocity, V vector equal to omega vector cross R vector. V vector is equal to omega R sin theta. If theta 90 degree, sin 91, so V equal to what? R omega. So instead of V, I am writing R omega. So L equal to M into R omega into R. So L equal to MR square omega. Ippa clear ayo? Doubt unda? Clear alla makkale? ഞാൻ സ്റ്റോപ്പ് ചെയ്യട്ടെ, ഞാൻ ലേറ്റ് ആയി എക്സ്പ്ലെയിൻ ചെയ്യാൻ പോയതാ, ലേറ്റ് ആയി. ഹർഷ ക്ലിയർ അല്ല? ഹർഷ ഇസ് ക്ലിയർ? Jishna, I will explain right hand thumb rule next class, because today I don't have time, because I have to start +2 class. So thank you. Thank you. We will see tomorrow. Thank you. Thank you all.